Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we will continue our learning on CO2 sequestration modeling using CMG software. And now we will extend our case with two-dimensional model. All right, so here, as you can see, I have a file, .dat file, which is our master data. This is 2D CCS. We include, of course, the structural trapping, hysteresis trapping, solubility trapping, and mineral trapping, right? So it's almost complete. Now I will even further extend this model with including water vaporization, right? The purpose of this exercise is to build the previous exercise with the addition of water vaporization. It is known that at high injection pressure of gas, water around the wellbore can vaporize from liquid into a gaseous phase, right? So hopefully this exercise will explain how to add that vaporization of water to the previous case. All right. So now I'm going to, maybe I can rename it directly, and let's add water vaporization, wet vap for water vaporization. Okay, and put it, of course, in Builder. By the way, in the next, in this video and the upcoming videos, we are going to use the later version, which is, 2023.20. So let's use it, drag it onto the Builder. Okay, expand. All right, IK to the view as usual. This is our injector, and open the IO control, title and case ID. We can add what VAP, water vaporization, or WV. This is case 6, for example. All right, click on OK. Okay, so that's good. And then we will navigate to the second step of the CCS process wizard. So let's find it here under component. Now in this 2023 version, we have process wizard. So it's a new feature, which is very, very, very helpful. Okay, so open the process wizard. Here we have, you can see here, process wizard step 1, choose a process from the combo box below, and a description will be displayed. So we have add or modify only geochemistry, low salinity water injection, good. This is for ASP, alkaline, surfactant foam polymer injection. Now we just select the carbon capture and storage. Okay, and then go to the next. Okay, so now at this step, we need to activate the option for water vaporization modeling, right? While keeping the default thresholds for reactions and for minimum residual H2O saturation. So let's see, select CCS trapping mechanism, CO2 solubility in water, of course, always selected. Model rock dissolution and mineral trapping with geochemistry, of course, because we already include the mineral trapping. And then model CO2 trapping by relative permeability hysteresis, all right. We still will include hysteresis trapping. And select CCS options, select activity model, picture recommended for high salinity. In this case, we are going to use B dot. Now, enable water vaporization to account for injectivity reduction due to salt precipitation. So you can see here, all right, we will have water vaporization, and that will result in injectivity reduction, or that will result in salt precipitation, which later on will result in injectivity reduction. So click on this one. And now you get more things here. Two-phase saturation pressure of the reservoir fluid. Use -1 if CO2 is never liquid. Okay, so we will use -1 here because we inject CO2 at supercritical condition. All right. And then aqueous phase saturation cutoff below which all geochemical reactions stop. This, okay, we use this default value. Residual aqueous phase saturation for H2O vaporization, and this is the keyword. We use 0.0001. All right, good. And then we click on next. Let's expand a little bit. Okay, so now we have input geochemistry data. So we will maintain everything. By the way, I make for this series, I use, previous version, older version of CMG to deal with the mineralization. Now I use a later version, and you can see in later version, we have process wizard and we have very good things like this. So hopefully, maybe later on, I can also maybe redo all the previous cases with this new version. Okay, so that we can learn about this process wizard thing. But let's say we just continue for now for water vaporization. So let's continue. Next. And also initial data for geochemistry next. All right, add new component for H2O. Yes, we take this one. Okay. And because we will add component for H2O. And in the next step, step 6, set rock fluid regions. Select rock fluid regions to use for hysteresis trapping. If any of the selected regions already contain more than one set, then the sets will be deleted. Okay, so we will use region 1. Next, okay, so this is step 7, input specific data for trapping by relative permeability hysteresis. Okay, as you can see, this is also a new thing for you maybe if you follow this channel because this comes in later version of CNG. Hopefully we can also learn about this, but for now, let's continue. And finally, step 8, choose wells, dates, and set injection composition. We just need to take this one. Okay, check the injector name, which is CO2 injector. And then let's click on finish. Change well CO2 injector. Okay, very good. Now let's go to simulation results output. And under the grid variables, we open. Let's find for our H2O. Let's go down. We are going to need this one. YH2O, mole fraction of H2O in gaseous phase because we will have vaporization. And WCO, sorry, WH2O. This one, mole fraction of H2O in aqueous phase. Click on OK. Good. OK. And save. Very simple, right? So the key here is, of course, the water vaporization, which comes in our process wizard. And of course, after that, after setting the process wizard, we later on input or we need to set the output for the H2O. Okay, so close the builder, close again. Of course, after this, we are going to run the model using this one, using the gem. Okay, waiting for start time. And of course, we don't need to wait for the simulation, during the running process. So we are going to stop the video here. In the next video, we will check the results. Of course, we are going to use the results, this one. Okay, so thank you so much for watching. See you again in the next video of CO2 sequestration modeling using CMG software. Thank you.